My work is based fundamentally on the ideas of Buckminster Fuller. I took his advice, which was study his ideas and make them your own. The conclusion I came to is basic geometry is in essence a catalog of modular building patterns, organized by structural and numerical constants. I developed a whole new measuring system and 3 orientation landmarks to organize these constants. To understand what I mean by this, let's begin by exploring what a sphere knows. A sphere knows how to build with fundamental structural integrity. One of the most fundamental structural numerical constants is the ability of spheres of the same size to pack together in a most effective minimum arrangement called the closest packed state. This means the spheres could not be closer together and each is touching the maximum number of other spheres. This is an example of fundamental structural integrity. It is incredibly strong and stable. The load placed on one part of the structure is communicated over the whole system. Fuller defined 3 layers of closest packed spheres as one cycle of initial growth. In his theory, the spheres produce a geometrical system, a polyhedron, the 14-sided vector equilibrium, or VE, or as the ancient Greeks called it, the cube octahedron. In his arrangements, the spheres are interconnected by triangles, the only self-stabilizing shape found in nature. The interconnectedness of essential parts is called synergy, and it defines how whole systems function in nature. Fuller titled his opus work Synergetic Geometry. A basic physical model of synergy is how 4 circles of the same radius can define the outside limits of a sphere. Each circle is in 60-degree orientation with each other. Where they intersect is a location in common we will define as white locations. There are 12 of these, and they organize the structural numerical constants that define structural integrity. If you connect them together, they form the VE, just like the spheres do. This system becomes our push-off start. All other systems polyhedra be relative to. There are 14 sides to the VE, 8 60-degree triangles and 6 squares. In the centers of the triangles is the first connection between the center and the outside limit of the sphere, which I will label the blue directions. In the 3rd layer of the closest packed spheres, there is room for a sphere of the same size in the center of the triangular group of spheres. This is where the all-purpose structural memories of a sphere exist. There are 8 of them. The 3 layers of closest packed spheres give us a size relativity field, a new way to measure. When you measure with spheres, you measure from one center to another center. From the center of the central sphere to the outside limit is 6 radii. To develop a structural measuring system that embraces size relativity, we need to choose a sphere that will be our U-Me ball. The radius of the sphere will be a scale number that you and I share, and the center of the sphere is our location in common. You and me will always be at the very center of any structure that we study. I call this scale number radius our belly button BB number. Like our navels are the cutoff knot from genetic codes before us and a symbol of our unique expression of the code, BB is a cutoff number from all structural measuring systems before and is a symbol of our unique connection to our new understanding of structure. I chose a regulation ping pong ball for a U-Me ball. Its radius will always be 2 centimeters. Therefore, BB equals 2 centimeters. All subsequent measures will be relative to this 2 centimeter scale number.